AOP to AOP. How this all started? It started on a summer day in 2022 when we were preparing our engagement for the CESAR joint undertaking, the third cycle, and we were trying to come up with ideas that could facilitate operation at that point of time. So this idea started getting mature, and at that point of time, we managed to share this idea with Fraport Greece, with our partners from Fraport Greece, and with Brussels and Copenhagen airports under the support of our coordinator. So, what was the triggering factor for coming up with the AOP to AOP idea? The whole concept was based on a daily routine of looking at the post statistics of the previous day of operation, as per which, due to the great number of flights to from the regional airports, inbound and outbound Athens, we could see that the reactionary delays which were induced due to a number of network issues on the day of operation were aggregating, and as such, towards the end of the day, you could see that we had aircraft rotations for specific airlines serving the regional airports that they could not be served. They had something like 1 or 2 hours of delay. It could be cases that an aircraft on the third rotation was planned to perform the fourth rotation, but the aircraft was already 1 rotation back. Why? Due to the cumulative and aggregated delays which were piled up in the course of the day. We try to see whether a better coordination could lead us under the existing ATFCM processes could lead us to better results. And this is how we started digging into this direct coordination of airports, but within the AOP NOP established channel of communication through ATFCM. So the idea was not to reinvent the wheel. We said AOP to NOP, but through a coordination of the airports directly under certain operational conditions that we will see later on. So this solution, the AOP to AOP, contributors are Eurocontrol, Copenhagen, Schiphol Airport, Brussels, Fraport Greece, Aegean, our airspace user, Indra and Indronavia. So we managed to have a team of competent partners. I have to give special credit to our partners from the previous cycle of CESAR, like Schiphol, that was so helpful in setting up the frame when we had to dig into the ATFCM related processes in the beginning and set the stage. But I also have to make special reference to the Hellenic Aviation Service Provider, our ANSP, through the new scheme that was set up almost 3 years ago. Our ANSP, which is now an independent organization, not part of the CAA and the wrong logo that we used in this presentation, has contributed to a great extent, even if not being a project partner. Another special reference has to be made to our contractor for the CESAR technical part of the documentation, which is ALG, and we are grateful for ALG supporting the whole consortium team for Solution 0346. So, the left part of the slide refers to graphical depiction of the AOP NOP, which was done back in 2017-2018 under the so-called Airport Integration Task Force, under the network manager. And at that point of time, we established the conceptual structure of how the AOP should be established. So it is really important to say that when we refer to an airport, we are not referring to an airport operator. We are referring to an airport node. Network-centric operations have the network manager, Eurocontrol, but the airport nodes have to define their own modus operandi, which might differ from airport to airport. So the APOC structure, which is a structured way of managing airport operations, it's a means of bringing all operational actors, stakeholders, under a structured manner at the position to exchange data with the network manager, while it might be that due to specific operational needs, this APOC structure might need to further coordinate with the FMP of the specific state, which might be the case under very heavy operations like in UK or in other states as well. So what we said is we are not changing the way that an airport node should communicate with a network, but we are also introducing this direct communication amongst the airport to see whether, under cases of a local imbalance which might be faced at the destination airport, whether a prior coordination amongst the airports could give us a proposed setup that might be accepted by the network manager. So what are we saying here? Imagine the case of a destination airport which faces a local imbalance. You name the issue which triggers the imbalance: terminal, apron shortage, weather. In that case, usually the response is that the ground coordinator, meaning the airport setup for managing ground operations, will ask from the local ATC to take some action, and this action back to back towards the FMP is to impose a regulation. So for a shortage in capacity, which might be triggered by any factor, it is highly probable that the whole network will be affected. Why? Because in order to resolve this imbalance at the destination airport, and this imbalance might be for 1 hour, 2 hours, depending on the case, instead of finding these specific flights, which might be candidates to have a shift to a later time slot, we might face the case that all of the carriers which are on the queue, and those carriers might be on the ground ready to depart for that destination airport, might have a serious effect without any reason. So this is how it all started. For the second solution, as Juan already pointed out, we didn't do something which was science fiction. We did a logical evolution of what we have today with the so-called variable taxi times. We all know that variable taxi times that we use in our ACDM configuration and within our future AOP platforms are created out of statistics that every airport, based on the local modus operandi, might decide that those variable taxi times derive out of 3 months of statistics for this apron area under this operational conditions. So variable taxi times are actually the default taxi times. So given how much technology has evolved and the new tools which progressively get into the operational development phase for every airport, that gives us the ability, the capacity to create more dynamic taxi times for that specific day. And having said that, these taxi times are more precise than the variable taxi times that we used to have throughout the years, but without creating any volatility to the network. That's the important message. We don't wish to create any volatility to the network. We just wish to create more precise taxi times for giving better predictability to the network. That's the essence of the second feature of the solution. So, overall, without getting to the more technical part of the Cesar features and enablers, the essence of the first feature of the AOP to AOP is arrival management. We are working within the context of arrival management. We are doing quite a lot on departure management, but the AOP to AOP was a trigger, a further trigger to further evolve what is already done under other projects for arrival management. Why? Because if we have the means to work at local level with our stakeholders, the possibility to shift one or two flights, which might be within this specific time period in which we face this imbalance, the end result might be better for local operations, but it might be much better also for the global network operations. So how does it work practically? I have my colleague Kostas Zographos from Fraport Greece, which might give you his feedback from the validation exercise later on. Let's assume that we have the imbalance at the airport. We have identified the period of the imbalance. We see that within this time period, there might be 4, 5, 6 candidate flights, which might accept a minor shifting in terms of the time. Meaning what? That we are in a position to ask this airline to accept a small delay for that flight, which, if it's accepted at local level, this is part of the updated AOP under the collaborative process that we all work at every airport, and this is then communicated to the departure airport. The departure airport, at that point of time, again through the collaborative means of their AOP, decides whether to accept a later departure for that specific flight. As such, it might be that there is no effect on the ops performance of the departure airport at that point of time, so they can accept this delay, or they might not accept. So it's a seamless communication between these two airports, and if it's accepted, then the destination airport asks through the network manager, provided that we don't have any further effects on the network planning, to issue a TTA for that specific flight. So, overall, the context of arrival management is very important because it gives us the capacity to manage in a much better way the overall performance at local, at network level. We have come to the point through a lot of evolution in the departure management to become as predictable as possible. But now we have to work on the other side as well. And working through arrival management, as you will see during the validation presentation, provides some concrete, tangible benefits. So a balanced approach between departure and arrival. For the second feature, we have already touched on this as regards the more precise calculation of the taxi times. Now, for the first feature, we have demonstrated that the AOP to AOP can work through two different methodologies. The first methodology is the TTA that I just discussed. The second methodology is the ACP. So the airport cherry picker was the methodology that was used in the validation in the second use case between two metropolitan airports, Brussels and Copenhagen. In the first case, we had Athens and Rhodes. Parenthesis. Which is the target audience of airports for such a solution? It might be regional airports with metropolitan airports over over, let's say, a geographical area which happens to be quite close in terms of the distance separating the airports. Why? Because when the distance becomes bigger, then the network effects to the local operation are the ones which prevail. So if we are closer to each other, we can be affected to a higher extent by the local part of the performance. So if you're under the same FIR or under two adjacent FIRs, it might prove to work better, while if you have a higher distance between the airports, it might not be the case. Other target audience airports might be airports which happen to host operational bases of carriers. So for those airports that may have a carrier with 5, 6, 7 aircraft operate out of, which is the case of the low-cost carrier on a number of airports around Europe, across Europe, then they may be willing to accept a delay in one of those flights so that the whole fleet planning is not jeopardized. So we have identified a number of cases where this appears to be applicable. I have very briefly described to you what is the process flow that for the TTA, that it starts from the imbalance identified at the destination airport. This imbalance is then dealt at local level. We try to identify the flights. If the airspace bureaus accept this and the communication, then it's done automatically in a seamless manner with the origin airport, and then we go back to the network manager. If this is accepted, then the TTA is issued. For the case of the ACP, would you like to comment? Peter and... Jeppe.
Yeah, thank you, Nikos. I'm Jeppe Nielsen from Copenhagen Airport, and together with Peter Kaleva from Brussels Airport, we'll explain a bit about the Copenhagen-Brussels part of the validation of this solution. And as mentioned, we use the airport cherry-pick procedure, and the main difference is with this procedure, we can make the regulation and the list of flights to be regulated in one action. That's performed by the FMP, which in our case was done by a proxy. And Peter will explain more about that. If we look a bit to the left side, the second left column, we have the airport of destination where the imbalance occurs. And then we can see there's an interaction with the airport of departure, which we have on the left. So this delay where a flight needs to be delayed at the departure airport, what we wanted to do, the solution is to establish a way of collaborating about the amount of this delay for each flight. And for this, we defined a new protocol, and it was not just a question of a proposal and accept, but also the ability to counter-propose. So there is actually some negotiation here, and that could take place more than once. The exercise took place over 2 weeks, 8 days in total. And we used the existing environments at both airports in terms of our AOP, our AODB, and ACDM setup, our already integration with the network manager. And what we then developed was a new interface, which has been specified in the technical specification of the solution, and which will be available. And the aim was then to validate this interface. And we also wanted to use the same interface for both the Athens roads solution as well as the Copenhagen-Brussels. So it's an interface that can be used for all between all airport pairs. And we also use the existing NM procedures, so no modifications when necessary there. So one part was, of course, the technical business-to-business interface. So a secure protocol that exchanged the information, and that was based on live traffic data. So it was a real-time simulation. As mentioned, it's not just a question of accept from the airport of departure. There can also be a counter-proposal. So we identified that there was a number of flows for this use case that we needed to test. We identified 8 in total on the left side to make sure that we have covered everything. And also for the users at the 2 APOCs, we developed prototypes in terms of user interfaces that the actual APOC users were able to use in real time alongside their other tasks. And on the right side, we see the Brussels Airport interface, where a proposal can be generated based on an identified imbalance. And then the proposal is sent to Copenhagen Airport in real time, and the Copenhagen Airport will receive it and is able to either accept, reject, or counter-propose a new delay if there's an issue with resources on Copenhagen side.
Yes, so maybe a short recap. So the objective was to create an airport-to-airport, AOP-to-AOP collaborative planning process to solve that local DCB at the airport of destination, which in our case was Brussels. And that was done by defining agreed times of arrival for specific flights, in this case, the CPH Brussels flights, and thereby resolving the DCB issue or imbalance using the ACP procedure, so the airport cherry pick procedure. There were some assumptions and inputs that we took before executing the validation exercise. First of all, it's important to know that the ACP permits the FMP to solve a short peak of demand balancing capacity or demand imbalance for a very limited number of flights. So it's only 4 to 5 flights. This is important. It's different than with the TTA procedure, where you have the possibility to have an impact on much more flights. The FMP role in our case was performed by a proxy at NM due to the fact there was a limitation of the ACP in the NMB flow tool today, for which a fix is still pending. But then again, this did not prevent us to perform the exercise as the flow described. So for the local airport capacity imbalance that we simulated at the airport of destination, meaning Brussels, there we assumed or simulated to have a lack of capacity of 5 Schengen flights during the afternoon/evening peak at Brussels Airport, which was affecting airport critical subsystems. So we identified 2 arrival flights between Copenhagen and Brussels as candidates in order to resolve the imbalance. We did a real-time simulation using the NM SATI pre-ops system, and the period where we simulated the imbalance was between 1900 and 20 o'clock local time. So what we did is we compared applying an ACP regulation versus a classical arrival regulation, and the results were quite positive. So the DCB imbalance was resolved during all test days using the ACP procedure, while this was not necessarily the case using classic arrival regulation. The total amount of regulated flights were reduced, and also we were also able to prove that there was a reduction in the total delay time created or generated by the regulations. In the table you can see a little bit more details, but we highlighted the columns of importance, so you can see that the ACP was able to resolve the imbalance and that there was a significant difference in the amount of flights being regulated and also the percentage of savings in terms of total delay amount minutes created by the regulations. So to summarize, mainly the validation exercise was able to confirm the concept clarity or the technical feasibility and also the positive performance impact. So almost all validation objectives were completed or proved. There were 2 where there was only a partial okay, and this was mainly related to the fact that live flight plan data was used as an input for the simulation, but real flights were not impacted or regulated. So that was the biggest reason why it's only partially okay. And additionally, the AUs, so the aircraft operators, were not directly involved. We have two main recommendations for further industrialization and broader implementation. First of all, evaluate or deploy with the together with the FMP once the limitation of the ACP functionality in the NMP flow has been resolved. So it's scheduled to be resolved with release in November 2026. And secondly, evaluate or deploy within an operational environment where the classic arrival regulation is not that dominant or frequent, and where ideally you have real-world local airport capacity demand or imbalances that occur regularly. So that was it for our side.
So, Costa. First feature, first validation. Athens to Rhodes Airport. And I would also like to call on the stage Mr. Nikolaos, who is one of the first contributors in the team, now serving under the new Heraklion Airport, which is under construction, but being a critical member of...
Nice to see you again.
Come, Nicola. So, the validation for the first exercise started, or the original plan was to do a live trial, which was indeed done, which was indeed performed, but in the process, coming close to the validation period, we had to face some operational disruption during that period. So the plan had to be flexibly adapted to the needs of those specific 2 weeks. But thanks to the very close support of our ANSP, at that point of time, we made it happen. And however, we had to also perform, which was, it proved to be quite useful, a number of simulated exercises before the live trial was performed. What needs also to be stressed is that the planning for the live trial on paper is a much different thing when you have to face the real case. Why? Because there was no intention at all to create any negative performance effect on the network. So we had to be really, really cautious not to create any side effects to the airline performance on that specific date, but at the same time try to ensure that there would be no network impact as well. So, who were the partners in this validation exercise? It was Fraport Greece, operating the 14 regional airports in Greece through the selected airport, which was Rhodes. We had Aegean Airlines aerospace users. Thank you, Nico. If you wish to join us on stage, please do. We will drag you later on one way. And of course, our ANSP. Our ANSP contributed through the FMP and through the local ATC unit at Rhodes. Therefore, I don't wish to go to the fine detail of the exercise. The methodology was exactly the same in trying to select during the time of disruption, of imbalance, the flights to be shifted. During the simulated validation, it was much easier to play with a number of flights, even with carriers which were not originally planned to be part of the live process. In the live process, of course, we had to focus only on the flights of Aegean, which, as a consortium partner, had to decide on the specific flights to be shifted. So you see that for a number of days we were doing simulation. When we came to the 26th of September, we managed to do this live trial that ended up with a clear benefit network-wise in the exact same manner like in the case of Brussels-Copenhagen. I just wish to give you the floor just to say which were the challenges from the regional airports, destination airports.
Good morning, everybody. Kostas Zographos from Fraport, Greece. Now, just regarding the live trials, okay. Oops. Okay. So, from what we saw, the tricky part was that since we had to do this with Aegean Airlines flights coming to Rhodes and originating from Athens, this was a short-haul flight. So, most of the flights affected at the time that we wanted to target were already airborne. So, we had to pay close attention to do that well in advance, and this was significant effort. But overall, as Nico said, we managed to do that on the 26th, and what we saw is that instead of imposing a conventional regulation, we did the process, and less flights were actually regulated.
Thank you, Costa. So we managed to get rid of classical regulation. Is there anything from the FMP point of view that we had to stress during the process from your side?
To be honest, once we ran it, for the next time lesson learned was that internally, the FMP in charge. Oh, thank you. I think I speak quite loud.
Please.
Okay. Good morning to everybody.
Mrs. Agapitou from the FMP, from the ENS.
Yes, I'm responsible for the ATFM now in HASP. So the way we run it, from our side, I want to be honest, I think we can internally do better. I mean to make the FMPs on shift more aware of what is expected from them. And it would be far more interesting if we could pick more candidate flights and run it through the day more flexibly. And I trust that Indra will offer you a better...
In the next phase, so
yes, a better tool.
This was mostly, because of the trial. I agree. We did have a lot of process to do. We did have a lot of process to do, but this was, first of all, it was due to the trial and the limited candidate flights that we had. This was, I think, the main reason. And technically, yes, when and if this concept is incorporated, I guess it will be technically more easier due to familiarization, first of all, because it was all new. The process was all new, both for FMP and the airport. And the tool is going to be further developed as well.
That's why we call it research, and at this stage, what we managed to demonstrate, and that I believe is the lessons learned for everybody, is that by making this direct coordination amongst the airports, we managed to save a classical regulation. And that was a part of a process which worked seamlessly, but when we will enter the industrialization phase, we will need to take into account all the operational processes and all the technical aspects which will make this process seamless with less interaction. And that's the other important element, that the human-AI interaction, the human-machine interaction, during the validation process as provided through the input by all operational actors, proved to be quite a seamless process without adding too much burden to the operational positions at both APOCs, at your airport operations, in the operations of the origin airport, while from the network side, it proved to be quite a straightforward process. However, the difficulty on the day of ops of not creating any effect on live flights was quite interesting, but we managed to do it.
It was difficult, eh? It was still
really?
in September.
So, what has to be stressed now for the second feature, and thank you for your contribution. So please, have anybody else? Yes, we'll come later. So for the second feature, the prediction tool, which gives us the dynamic taxi times, was there as part of a simulation, a simulated exercise, so that we saw that we had this added value of better prediction of the taxi times. We have registered those results that gave us the confidence that we can be more predictable in terms of our timestamps. And that's why in more than 50% of the cases, we were definitely more accurate than by using the default exit times. So let's summarize the results of both features. First one, we did validation. Please stay here. We will be together with the team. For the first conclusion, solution 346 is an evolution of what we do today. So we take the ATF SIM process and we make one step forward from the perspective of arrival management. It's technically feasible, it is mature, we demonstrated that airports can cooperate in a seamless manner and we can do this interaction with the network. It can be applied with any methodology, ACP, NCP, so it works effectively in both cases. The target time of arrival concept, as already demonstrated under other projects, is technically mature and can work for that case in order to save those classical regulations and be more targeted to those flights which might contribute in alleviating the effect from the imbalance. Taxi times, it might seem easier, but it's not. Why? Because we start getting into the essence of how we need to make the best use of all these AI tools, which gives us mature, more precise timestamps by the superior processing, which was not the case some years ago when we were embarking on our ACDM journey. A technically robust solution which is operable. We did it, we operated, we managed to have operational flows which were not creating any further burden apart from adapting our operational functions to the case of for incorporating arrival management. While it appears at this stage that it's a solution which, if we make this incremental improvement in how we do ATFCM at airport level, is just the next step, so it's ready for industrialization. In terms of the overall consolidated results for the feature one, we managed to prove that at local level we had a better punctuality by almost 3 minutes. The predictability was improved by, again at local level, by 7.4 minutes per flight. And for the feature two, we came to the point that we can reach even 1 minute of flight at local level of savings by having more precise taxi times. The human-machine interaction, of course, is improved, as we said. Tasks are clear; they have to be adapted, like every operational process which enters. Which needs to be taken at frontline ops. And coming to the cost-benefit analysis that you will excuse us, but we have to share the more financial aspects with our SJU during the maturity exit gate. But at this stage, we are in a position to share that we have a quite positive net present value out of the CBA. More data to be disclosed to SJU, and then we will be in a position to share with you as well. So I would kindly ask all the FASTNet 0346 team also, so Juan, Eric, please, the Brussels team, Nikos Vasilakis from Aegean, Miss Agapitou. Do I miss anybody from the team? Christos Papageorgiou, yes. David. Where is Alan? Where is Alan? Alan, yes. Αγγελική. Έλα. Έλα.
Έλα, μόνο εγώ γυναίκα. Λοιπόν, νομίζω πρέπει να γυρίσουμε έτσι, όπως Αμερικάνικους γάμπους. Προφίλ για να φορέσουμε όλοι. Profile.
This is the 046 FASTNet team, and sincere thanks to all.